Hello, folks. Welcome to the latest Tailscale webinar. I can see the attendees starting to filter in now. I always like to wait 1 minute to make sure that everybody has a chance to join. So while we wait, I would love to get the chat started. I'd love to hear where people are dialing in from today. We usually have a pretty good worldwide representation. So if you would mind sharing where you are dialing in from in our webinar chat, it would be really great. And we'll wait till about 2 minutes past, and then we can get started. While everyone's dialing in, I will share my screen. There we go. Hopefully everyone can see my screen okay. I'm sure I'll get some notifications from my wonderful co-host and operations manager in the background, Tim, if there's any problems. We'll just wait until 2 minutes past the hour, and then we'll get started. I see in the chat we've got some great representation from around the world, the UK, where I'm from, the west coast of the US, where I live now, South America, various parts of Europe. I hope everybody in Europe is enjoying the European Championships right now. Okay, I make it 2 minutes past the hour. Let's get started. Some housekeeping before we kind of head off along our journey. Please make sure you're respectful in the chat. Anybody who's found to be not respectful will be promptly removed. This is a live webinar and there's lots of people in here. So please make sure that you keep the comments respectful. This is a live webinar with live demos. I am at the behest of the demo gods here. There's a lot that could go wrong. I'm dealing with a particularly tricky topic around GPUs and quotas. I appreciate everyone's patience. I'm going to troubleshoot things live. This is about as real a webinar as you're going to get. So if we do run into issues, I will make sure to explain what's happening, why that issue is happening, as I understand it, and what we're actually going to do to fix it. I'm sure there'll be lots of questions as the chat kind of scrolls along. Please make sure to ask the questions in the Q&A part of Zoom rather than in the chat. If you throw a question out in the chat, it's moving very, very quickly. I am likely to miss it. So if you do want to see your question answered, please make sure that you ask it in the Q&A tab on the Zoom bar. That way I can address it during the moments where I'm waiting for things to finish. And then finally, at the end here, there will be a QR code that will be shown that will give you the opportunity to provide feedback. We are kind of preparing these new webinars with a new format that are more live and less formal. And we'd love to hear your feedback about what you think of the content that you see today. So please take a minute at the end to scan that QR code and open the feedback link. Just think of it as one of those customer service things where they ask you to hit 5 at the end. Just take a minute to make sure that you give us some feedback. We love building this content for you, but we want to make sure it's the right kind of thing that you want to see. So quick introduction for myself. I'm Lee Briggs. I'm based out of the west coast of the US now. Previously, born and raised in England, but now I live on the west coast of the US. I have a Twitter or X handle, whatever it's going to be called this week, at BriggsL. You'll see some infrastructure definitions today that I've built with infrastructure as code, which I'll take you through. That code will be shared at my GitHub at JackStorm. And I also have a website, leebriggs.co.uk, where I write about all things Tailscale in a more informal manner than our wonderful Tailscale documentation. So what is the GPU availability gap, and what is Tailscale's solution to this? Well, the candid question is, have you tried to get a GPU lately? Whether it's buying it for your gaming rig or if it's for running inference workloads in the cloud. Demand is outstripping supply as we go through this AI boom, understandably. I think everybody on this call will have seen NVIDIA's stock price recently. There's a reason for that. They are printing money in the form of GPUs. And if you can find some, they're probably pretty expensive. So, the ability for you to drive costs down is really at the behest of your infrastructure provider. Cloud providers have implemented quotas across the board. I had one hell of a time getting the GPUs that I needed just to run this demo. So it's been really, really difficult for me as an individual with the backing of a wonderful company like Tailscale to get the required GPU quota that I needed to be able to actually showcase what I wanted to show you. So if that's something that you're also experiencing, I'd love to hear about it in the chat. But generally, These GPUs that are being built that are really, really vital for these inference workloads are just being gobbled up by the likes of Anthropic and OpenAI and all the other wonderful providers of large language models. What that brings as a problem is if you built all of your existing applications in one provider and you can't get those GPUs inside your provider or enough to kind of manage your inference workloads, what do you do in that situation? Well, in the form of a very crudely drawn graphic, if you are building infrastructure in a cloud provider, which is represented by this cloud here, and your web application needs to call an LLM, when you're inside the cloud provider's network boundary, that's an easy problem to solve because you just call it and you don't need to worry too much about what's actually happening between those two connections. However, as we've worked with customers, what we're finding more often is that you're actually running into a situation where you have to do something like this, where your application is in a one cloud provider because that's kind of the cloud provider that you know really well, but you can't get the actual GPU quota that you need from that cloud provider. So you start to source them from other places, whether that be another hyperscaler, whether it be a more niche cloud provider. And of course, that immediately brings you to the problem that you have to go through the big, scary internet to be able to actually use this GPU that you've provisioned and run this large language model. So what do you do when this happens? Well, first of all, I actually looked at this problem a little while ago when I was trying to run Olama on a GPU, and I found this GitHub issue that said, yeah, you can actually secure the actual Olama implementation. And this is not specific to Olama. If there's other models that you're actually trying to run or other, LLM kind of wrappers that you're trying to run, they all kind of have the same problem. They say, well, you need to put a web authenticating proxy in front of it, right? And obviously, as an employee of Tailscale, I didn't really like this idea because, first of all, there's a lot that can go wrong with my configuration of that Nginx basic auth or Caddy or whatever other web application that I use. A lot can go wrong there. And also, the internet itself is big and scary, as we already mentioned. So I really wanted to be in a position where I could encrypt the traffic between my web application and my GPU. So that's enough slides. What does that look like in real life? Well, let's take you through a short demo or a medium-sized demo about how I went from running an LLM on my local laptop to running it in a cloud provider in a quote-unquote production-grade capacity across two different cloud providers. So I'm going to do this real quick, and I'm going to go to my machines. So I have a Tailscale account here, and I've set up a few different devices, and I'm going to head to my terminal, and I'm going to show you what it looks like to run a web application with a large language model behind it. And whoever said may the odds ever be ever in your favor, I really appreciate that because we're into the live demo portion. So what I'm going to do here is I'm going to run a web application called OpenWebUI. If you're not familiar with OpenWebUI, it's a wonderful product that will allow you to build your own chat interface with a large language model. And in this particular Docker Compose, I'm just going to bump this up a little bit like so. In this particular example, I'm actually going to run the large language model that I'm going to use for OpenWebUI on my local machine. And the reason that I'm doing that is to show you how frustrating it can be to run it on your local machine. So this is a Docker Compose file. It's come basically straight from the OpenWebUI Git repository with the addition of a single environment variable so that I can actually avoid messing around with some WebUI auth because this is all running on my local laptop. I'm going to go over here and then I'm going to open localhost port 3000. And you should see this is OpenWebUI that is running on my local laptop. And if we go into the settings in here, into the admin settings, you can see I can actually look at some connections that are actually instantiated with OpenWebUI. Olama is running in another Docker container, and I can verify that it's actually connected, which means that I can now run a standard interface with an LLM by asking it a question. So I'm going to go to new chat and I'm going to pick one of the random ones here. So I'm going to ask it to tell me a fun fact. I need to make sure I select my model. Olama in the back end and OpenWebUI will allow me to use any of the models that you can generally find from things like Hugging Face. Llama 3 is just one of the most reasonably sized ones. So I'm going to choose that, and then I'm going to hit send message. Now, you're going to notice this is particularly sluggish, especially if you are used to the speed of some of the cloud-provided GPT interfaces. It's going to take a really, really long time to render this, and it's going to take a really, really long time to actually calculate the thing that it needs to tell me. Of course, this is running on my local laptop with a standard ARM CPU on my MacBook Pro. There isn't really much of a GPU acceleration in here. This is not really usable on a day-to-day basis for me who wants this my own private LLM. I can't sit here and wait 10 to 15 minutes for this to finish rendering. So I'm going to stop that and save us all the pain of waiting for it to struggle. What I really want to be able to do is leverage a GPU. And a GPU is going to really accelerate this capability without me having to do a whole bunch of stuff. Now, as I already mentioned, getting GPUs is really hard. So let me take a look here in my Azure console. In this hypothetical example, I am building all of my applications and I want to create this interface, this private LLM within Azure, because if you think of it from a hypothetical perspective, all of my infrastructure is already in Azure, right? If I go and take a look, you can already see, I don't have quota for actual vCPUs, but if I go in here and look at the actual availability for me of GPUs, you can see my type GPU here. I have insufficient quota for basically every GPU that I would really want to use in this situation, right? I can't actually get a GPU from Azure that is going to be able to actually be a backing power for my actual large language model here, which is obviously a problem because I need to be able to provide this to people within my organization or as part of my general day-to-day workloads, and I just don't have the GPUs. So I had to look elsewhere for my GPUs. Luckily for me, I could get some GPUs from Amazon Web Services. So what I did is I built a Terraform configuration that actually provisions a GPU in Amazon Web Services. So let's go and do that now. And I need a new terminal. I need to make sure, let me just close this down real quick. So let me make sure I have valid AWS credentials. I do. And then let's go into my Terraform configuration. So here I've got some Terraform that is going to build a virtual machine or an EC2 instance in AWS. It's going to create a VPC. And as a result, it's also going to install Tailscale on the AWS EC2 instance via some user data. It will then allow me, even though this particular machine is not going to be accessible from the public internet, to leverage that particular GPU without actually having to do any of the really hard work of securing that particular backing LLM with Ollama from any nefarious use. So while we wait for this web instance to load, I'm going to go and take a look in the QAA. It looks like Tim already picked one up. Looks like there's one about recording. While we wait for this to run, I have a question for the general group that's going to go out via the polling system. I would love to know if you're already using Tailscale or if you're using it at work or at home. I'd love to see if you're already using Tailscale. My wonderful counterpart Tim is going to send that poll out so everybody gets to do that. Or I think I can actually do that. My apologies. So let me just go into more polls and quizzes. Launch. There you go. So what's happening here is it's creating the AWS instance. In the background, it's installing Tailscale as part of its user data. And it's going to give a couple of capabilities as part of Tailscale. What I'm waiting for here is the actual backing user data to run on the AWS instance. So it's going to start up, it's going to install Tailscale automatically. And then what it's also going to do is install Ollama, the backing data store for my large language model. And then it's also going to pull one of the models for me so that I can actually use it. Lovely to see of the attendees here today that we're at about a 90-10 usage of Tailscale. That's really great to hear. We'd love to hear in the chat what sort of usage of Tailscale you're doing, whether it's your home lab or whether it's at work or whether it's all ready to actually allow you to be able to talk to GPUs and other cloud providers. I want to hear about your use case for Tailscale. It's always great for me as a solutions engineer to be able to hear what's actually being used on the Tailscale side and how people are using it. So while we wait for this device to register, I'm going to head into my AWS portal, and I'm going to go into EC2, and I'm going to search for my GPU instance, AWS GPU, like so. And so you can see my instance is running now. It's still initializing. If I go and take a look at this and go into my instance settings, uh, edit user data, this will actually show you the user data that's created. So if you've installed Tailscale on a Linux box before, you'll know you need to do some IP forwarding. So that's been set up as part of the user data. And then we're also going to actually use our wonderful install script, which detects the operating system. And then it's going to use a retry mechanism to actually install Tailscale, download it, and we're going to install a whole bunch of stuff in here. I've used user data that's part of a Terraform module that I put together that actually templates out all of the different inputs for the Tailscale client. You can see here that I'm adding a GPU tag to this particular instance so that I'm able to use the ACLs within Tailscale to segment access to things. And then if we scroll down a little bit more, you'll see that I'm going to configure the NVIDIA runtime. I am using an AMI here that already has the NVIDIA drivers installed on it. So I need to make Docker aware of the NVIDIA runtime. And then I'm going to restart Docker, and then I'm going to run Llama with all my GPUs, and I'm going to pull the actual Llama 3 model. Just take a quick drink. Looks like there's a lot of great responses in the chat here around how people are using Tailscale. So lots of use of Home Lab. We'd love to hear that. Glad to hear that we displaced WireGuard for some people. Looks like there's somebody already using this to connect an AWS GPU Kubernetes cluster. Really excited to hear about that use case. If you're interested in talking to us about it after the webinar, I'm actually going to leverage some of this stuff as I go through the productionizing of what I'm building here and with a Kubernetes cluster later. So I'm looking forward to getting that part of the demo. We're still waiting for the Tailscale device to finish registering, so it's going to take a few more minutes. And well, as I already said, there's a lot that could go wrong here, so we'll see what this looks like. While we're waiting for this, you'll notice obviously that my MacBook Pro has got Tailscale installed here. If you take a look at some of the access controls, I've already defined my GPU, which is owned by me as the admin of this particular tailnet, which is my private tailnet. I haven't implemented any ACLs at this point. What I could do is allow access to only specific devices to the GPU tag, and I could restrict it to the port that Llama runs on, which I think is 11343 or something like that. And that would allow me to really lock down who's able to use the GPU and who's able to leverage it in a certain way. One of the things that will obviously come up as these GPUs become scarce is that they are obviously very difficult to to segment out in a way. And so what I could do is lock this down with some ACLs that would give me the capability of being able to disallow people from leveraging this, whether it's your web application or whether it's individual users. Still waiting for Tailscale to finish running. Definitely getting to the point where I would have expected it to register now. So we get to have all these, all this waiting game. It should take around, I think a lot of the time that we're waiting for here is the actual finishing of the user data to run and install in Tailscale. So just taking a few minutes, and we should see our AWS GPU in a moment. Just a quick, Leyland, if you wouldn't mind sending that question into the Q&A section. It's quite long, and I want to make sure that I'm able to address it during the next break section while we're waiting for things to run. So, if you wouldn't mind putting it in the Q&A section, that will be really great. I'm going to have a look here and see what's going on with my GPU unit. It looks like it's passed checks. The moment of truth, folks. Is this going to register with Tailscale correctly in my automation, or am I going to have to log into the box to actually fix it? Let's have a look and see, shall we? I would have expected it to register by now, so I'm going to be extremely patient. But while we wait, I am going to grab this instance public IP. Generally, I wouldn't have used a public IP here. I would have put this behind a private NAT gateway, but, things can go wrong. So I've actually added an SSH key to it. And I need to actually double check that I've opened the SSH port on here. So I'm going to go into my security. So you can see in the security groups, I've got this in a public subnet so that I can get the direct connections that you need for Tailscale to be able to work. There's lots of problems behind managed NAT gateways. So the only inbound rule that I've currently got here is the Tailscale UDP vault 41641. And obviously that gives me the ability to create those direct connections. Let's go and have a look at what's actually happening here with this particular issue, with this particular instance, because I've run this probably 30 times in the last couple of days, and it worked great. So for some reason, it is not registering correctly. Let me go to save rules. Oh, there it is. It worked, folks. We got our AWS GPU. It has been registered. You'll also notice that just as I added SSH access, which I no longer need, so I'm going to remove this because I don't need SSH access. You'll notice that I added the SSH flag to this AWS GPU, which means that I'm able to use Tailscale SSH to actually access the GPU itself. So you can see I've got an SSH ACL in here that allows me to log in via tagged GPU. So let's go and have a look what actually happened when this finished. So I can go SSH like this, and then AWS GPU, like so. Make sure I remove that. So what happened there was that I already logged into a box called AWS GPU earlier, and I already had a host key on there. So it's just had to remove this from my host key. And so what's actually happened here? Well, if I go to my root user, you can see I now have Ollama running on this particular instance, on this particular EC2 instance, with port 11344 is forwarded, but I don't need to expose this to the public internet. And if we run NVIDIA SMI-L, you can see this has actually got a GPU on here. So I'm able to get all of the benefits that I would need from a GPU to run my large language model. It's not a particularly powerful GPU. It's not an NVIDIA H100 or NVIDIA or any of those lines. Along those lines, it's just a Tesla T4, but I should still see a much better performance from my implementation of OpenWebUI. Let's go and have a look at what that looks like. So what I have here is a Docker Compose -R, which is no longer running Ollama locally, and it leverages the Tailscale IP to connect to the Ollama base URL. So this is OpenWebUI connecting remotely over a private connection using Tailscale to a remote implementation of a large language model with a GPU behind it. So let's grab my Tailscale IP here. I'm going to do Tailscale IP equals this, Docker Compose -F, like so. And of course, I haven't had to do anything from a connectivity perspective in Amazon Web Services to make this work. All I need to do is install Tailscale on both sides of the equation. And as a result, I'm now able to actually communicate with this remote GPU from my machine. And let's go and have a look what this looks like in terms of a change in our performance for OpenWebUI. So let's have a look at, again, the settings on the back end. So we go into the admin settings here and go into connections. You can see I've got an Ollama API here. And at the moment of truth, my connection is verified. I could take a look and see what models I have available. I have Llama 3 available here, so I can still leverage that. And then I need to select my model, and I'm going to do the show me a code snippet here. Notice the difference. And again, this is all over a private connection between two Tailscale clients. What will happen the first time I send a request to Llama 3 is you'll get a slight bit of latency while the connections are established between my machine and the remote machine. But look how much faster this is when I'm actually generating the initial response. I'm going to let this finish because what then I'm also going to do is I'm going to ask it another question. And you'll notice that the response comes back almost immediately. Make the header blue. Straight away, I'm getting a response. So I'm already able to actually leverage the power of the GPU behind the scenes without having to do really anything to secure it from the public internet. Now, as I already mentioned, generally in most situations, I wouldn't put these EC2 instances on a public internet because I don't really want them to have the actual public interface. The reason that I've done this in this particular example is for two reasons. One, AWS managed NAT gateways take forever to provision and it just slowed down the whole process. And B, I wanted to get a direct connection. And there are design issues with AWS managed NAT gateway that mean that you don't necessarily get those direct connections. However, this works great behind a private subnet. So I could actually put this Olama instance or this GPU instance behind a private subnet with no real problems. So this is great. I now have a great, amazing working version of OpenWebUI, which is backed by a GPU and Olama on the backend. But this is all running on my local laptop. That's not really good if I want to use this on an internal organizational level, if I want to share it with my colleagues, or if I just generally want to make it available all the time. So what I now want to do is think about how I'm going to make this more usable across a more wide scale manner. So what I've done is I've provisioned two Kubernetes clusters, one in Azure, where again, if you remember in our hypothetical example, where I've provisioned all of my other applications that need to leverage this particular LLM, one's running in Azure and one's running in EKS. And I have provisioned the Kubernetes operator, the Tailscale Kubernetes operator on both of those particular Kubernetes clusters. What I now want to do is run OpenWebUI where all my other applications are running in Azure, and I still want to be able to leverage the GPU capacity that I have at my disposal in AWS. So what does that look like? I'm going to close down my local version of OpenWebUI, and I'm going to go into a different directory here into my Cube folder here. So I have an implementation. I'm going to bump this up a little bit so we can make sure everybody can read it. So I have both of my implementations here, one of Olama and one of OpenWebUI. So what I've got is a Olama Helm chart, and let's just make sure I am on the right host. I am. So I have an Olama Helm chart, and what I'm going to do is install Olama into this EKS cluster with a few values. So I'm going to enable GPU integration. I'm going to leverage NVIDIA GPUs because I've got Teslas on the back end. I'm going to specify one GPU because the instances that are available to me only have a single GPU. And then I'm going to make it pull this model here. And then there's a couple of important pieces here around how Tailscale operator exposes services, because I want things that are outside of the cluster to be able to actually talk to this particular implementation of Olama. I don't want an ingress, and I obviously want this to run on GPU nodes. So I'm going to do Helm install Olama, blah, 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 blah. If you're familiar with Helm and all, this will all look pretty standard to you. And I'm going to run this. So now I have to wait for a few minutes. So I'm going to show you what's happening. So what's happening in the background here is it's installing Olama, and then as part of its initialization script, it's actually going to pull that 4 GB model from the repository that it pulls the actual large language models from. It's going to pull those into the actual container itself, so that I have the actual model running itself. While I'm waiting for that to really finish, and there's one other thing that I have to do here. Yes, Eugene, the source here is the Tailscale expose on the service. Let's take a look at that just to make sure that we know what's happening. So I'm going to do get service and Olama, like so. And if I do -o YAML, you can see it's got a annotation on here called tailscale.com/expose true, right? And the Tailscale operator in the background has found that annotation, and it's done something really special. It's created a pod in the Tailscale namespace that exposes this particular service as a Tailscale address. So if I go back to Tailscale, the Tailscale console, you'll see I've got this Olama device here. This will actually allow me to talk directly to Olama running in a Kubernetes cluster. So let's take a look what that looks like. I need to do curl HTTP. What pod is it? It's this one. Like so. I'm able to communicate with this Olama that's running again in this remote cluster without actually having to do anything on the actual pod itself. It's created a service that is running remotely inside the Kubernetes cluster. And if I take a look at the nodes that I have on this cluster here, and I actually want to look at the pod that is running Ollama, like so, if I take a look here, ooh, typing too fast, like so. So let's take a look at how I've set this particular cluster up in a little bit more detail. So this is running on this particular node here. Let me find the actual node that it's running, but it's been scheduled on. No, I'm just going to do this actually. A bunch of these nodes are actually just standard system nodes, but some of them or one of them at least, should be a GPU capable node. Not that one. It's going to be the last one that I look at, isn't it? I think it might have been this one. Like so. Yes. Okay. So what I've actually done on the cluster itself is install the NVIDIA device plugin, which will actually discover all the GPUs on the host. And you can see this has actually added a bunch of information about how the GPU is capable of working. And then the actual Ollama instance has been scheduled on this host, and I've exposed it to my entire tailnet via a single service that I exposed with via a single annotation that I set on the actual Ollama instance, which again will allow me to be able to actually communicate between these two different Kubernetes clusters. So that's great. I've got Ollama up and running. That's wonderful. How do I actually get Open Web UI to now communicate with this version of Ollama? Well, of course, I need to install Open Web UI. And first of all, I need to actually switch to my AKS instance. And while I get the opportunity here, I'm just going to pause really quickly and actually look at this AKS operator here. I'm actually able to communicate with the cluster directly through the Kubernetes operator, the Tailscale Kubernetes operator. So I'm going to switch to my AKS nodes here, my AKS cluster here, and I'm excellent. I'm on my actual AKS instance here. And now I'm going to install Open Web UI with a whole bunch of values, right? And then I'll go like, oh, wait. Actually, no, I'm not going to do that because I need to do something else first. So I'm going to install that. So what I want to be able to do for Open Web UI is I need to be able to communicate with the Ollama via the internal mechanism within the Kubernetes cluster. So how do I do that? Because the actual Kubernetes cluster in Azure knows nothing. It knows absolutely nothing about Ollama itself, right? It doesn't know anything about Ollama, and it also doesn't know anything about the remote cluster because Tailscale is not running within this particular cluster here. So what I have is a special service that you can build with the Kubernetes operator that will allow me to expose a remote Tailscale device within this particular cluster. So you can see here we've got these annotations, and I've got another annotation that specifies the Tailscale FQDN. And just as a reminder, this is the Tailscale FQDN here. You can see it in the Tailscale console, Ollama. What this will allow me to do is within the actual Open Web UI implementation, it will allow me to be able to communicate across two Kubernetes clusters in the same way that I would from my local laptop to that AWS instance that we built earlier. So let's add this particular service to create the service in the local namespace, in the local cluster, sorry. And you can see it's got Ollama external name, external IP is here. And then if I do get pods -n Tailscale, you can see it's created another pod for me in this particular cluster that is related to that is allowing me to create this device-to-device connection between Azure and between EKS. So I'm going to wait for that to register. Here we go. And now all I need to do is install the actual Open Web UI. What's really unique about the way that this external name service works here within the actual cluster is that the Kubernetes doesn't need to know anything special. It doesn't need to know anything about the Tailscale remote namespace. It actually creates a local service inside the default namespace called Olama, and then the Tailscale pod that's in the Tailscale namespace that got created here proxies that request to the remote cluster for me, right? So when I install Olama, this is going to allow me to be able to communicate across two different clusters. So I'm going to run the install of Open Web UI. I'm going to wait a few moments. While I'm waiting for that, I'm going to go and take a look at the Q&A. Open. Just to check, do you have an idea what the egress? I'm going to move this up here so that I actually don't have to stare down at my second screen. So the question here is really around, Leyland, is around how egress happens. Now, generally, if you're going through a managed NAT gateway, you're going to be charged for all that egress. My recommendation when running Tailscale and having that kind of outbound connectivity is to run it in a public subnet. You will be charged for the public IP address nowadays with AWS. But I would recommend running it in a public subnet because for two reasons. First of all, it allows you to get direct connections between two devices within Tailscale. And secondly, you don't pay egress fees at all. So there is obviously data transfer considerations between availability zones and all that kind of stuff. But generally, if you don't kind of transition or egress through an AWS managed NAT gateway, you shouldn't see that much problem with regards to egress fees. So I would recommend kind of doing like that. If you want to talk more about this from a solutions architect perspective, I'm on the solutions architect team. I have some wonderful colleagues that work with me. We'd love to have a further conversation about how we can make this easier and better for you and kind of drive those egress fees down. And that's done. I've been working SageMaker Inference. How much does it cost to keep this EC2 running your LLM? In my case, we're wrong. So the price is obviously, I can't recall the price of this particular EC2 instance off the top of my head. One thing that I did consider doing here for this particular webinar was showing how you can do this with Carpenter to have ephemeral nodes provisioned. I am using Carpenter with Spot for a variety of different things. But obviously, like SageMaker is a solution here if you are able to kind of use the on-demand nature of AWS. It's really worth remembering here. I'm using AWS personally because I could get GPUs from them. There are lots of customers that we've spoken to that can't get GPUs and they need actual always running GPUs and they don't want to use SageMaker. So in that particular case, this particular solution is applicable to any cloud provider. It's applicable to DigitalOcean Paperspace. It's applicable to Azure. You could reverse the two different sides of this particular connectivity tree and have all your applications running in Azure, where all your GPUs are actually running all your applications running in AWS and all your GPUs running in Azure. The reason that I've actually used the Kubernetes implementation here and Terraform as well is to show you how capable it is of being able to do this across all of the different cloud providers, regardless of whether you are already running applications in there. Hopefully that answers your question. But would love to hear any more about what you would think is a potential benefit versus SageMaker. So while I did my little pause there, I'm also going to send out another poll around, and I never ended the other one. So I'm going to send out another poll. I would love to hear if you folks are having problems getting GPU access. I'm going to end this one. I would love to hear if this is a problem that you're running into. Are you having problems getting GPU access? There's a reason I'm ad-libbing a little bit here while I'm waiting for this to finish. The reason for that is, and I'll tell you a few moments in that for towards the end here, but I'm ad-libbing intentionally here while I wait for some things to happen on the back end. So it gives me a chance to take a break, have a little water break, and ask you some questions on the audience. While I wait for the results of that poll to come in, I'm going to show you what actually happened with my install of Open Web UI. If we go back to my Tailscale instance, you'll notice there's an Open Web UI device here as well that's appeared in my tailnet. because obviously I don't want all of the folks on this particular webinar to immediately bombard my Open Web UI instance and start asking it questions with my GPU behind it. So I haven't exposed Open Web UI to the public internet in this particular case. And what I've done is I've created an ingress that is actually very similar to the OLAMA interface. I've created an ingress that exposes Open Web UI to me locally. So my my Open Web UI is only available to those folks that are actually connected to my tailnet without having to worry about securing Open Web UI at all. So let's take a look at the ingress here. So you can see I've got an ingress, and I'm going to open this up a little bit. You can see that I've set an ingress class name of Tailscale. The Tailscale operator that's installed on this cluster immediately recognized that ingress class name and created an ingress with a particular host name that's related to my tailnet. And then that is able to limit who's able to access Open Web UI. It looks like we're having a 50-50 response to the GPU access, which I think is really interesting. Literally 52-48, so about as close to 50-50 as you can get without really being there. But the host name, just to go back to what I was talking about, the host name here is set to Open Web UI, which means I can now give myself the ability to go and actually look at my Open Web UI like so. So remember, this was my local host version. Let's do this. And of course, I'm connected to it over Tailscale. So if I disconnected from Tailscale, I wouldn't actually be able to access Open Web UI. This is not a good sign. It seems like I've got a problem here. So let's debug this live. What is happening behind the scenes? No, it looks all pretty good to me. Interesting. Oh, I just need to be a little more patient. So now I've got Open Web UI running on my tailnet. Anybody who is able to connect to my tailnet is able to access this Open Web UI, and I can go and take a look in my settings and go into the admin interface and look at the connections. You'll notice that the connection for the OLAMA API is still looking like it's an internal Kubernetes address. But if you remember, I created a service of type external name that will proxy those requests over to AWS for me. So I don't actually need to do a whole bunch on the Open Web UI side, and it's still authenticated. It's running over an encrypted current connection. I can use Tailscale's ACLs to be able to segment the access. And the moment of truth, let's just verify the connection. Excellent. I can connect from my Open Web UI to my remote address. So this is connecting Azure with AWS. Doing this in a traditional manner is an incredibly complicated process involving site-to-site VPNs, involving a whole bunch of different stuff. And I've been able to do it with around 100 lines of YAML, or even less, maybe 20 lines of YAML. And I've been able to create a site-to-site connection between these two different things. You'll notice that if I go and look at my model, my Llama 3 model is available. I did upgrade the GPU on the Kubernetes cluster. So let's ask it a question. Explain options trading. Oh, I did not select a model. Let's do that. I definitely want to do that. And again, this first response is going to take a little second while it actually establishes the correct connection. But again, we're getting great performance from our large language model here. And again, this is two different production grade-ish Kubernetes clusters that are connected to each other. And I'm getting great performance. As you already mentioned, that first connection has a little bit of latency. But if I ask another question, let's ask it, should I buy GME calls or puts? The second response is way faster. And of course, in traditional large language model, it's not actually providing me any financial advice. So I'm obviously not going to deal with GameStop because that is going to be terrifying to me. So that is basically going to end our demo here. If there's any kind of follow-up questions that folks really are interested in, would love to hear them. I did see one from Morton. Please make sure you ask that in the Q&A section of the chat so that I can come and look at it in a few moments. We've got about 15 minutes left, so I'm going to follow up with some questions, with a few questions and a final poll. And then I'm going to kind of close out with the feedback. So bear with us. A bit in the weeds here from Alex. What's the latency on the request here? Does it connect over a relay node? If you're going through a managed Kubernetes clusters, presumably you need to navigate the NAT on both sides, right? That is definitely a concern here. So when you add Tailscale to Kubernetes, there are multiple layers of NAT that you have to traverse. The first one is that you have to go from the Kubernetes pod CNI out to the internet, and then you have to go generally through a managed NAT gateway if both sides are private. However, the latency I'm getting, because both sides of the hyperscaler sides like Azure and AWS are both in the West Coast, and so they're actually using the same relay nodes. So the latency is generally between 10 and 20 milliseconds. We do have patterns that will allow you to be able to get direct connections even with Kubernetes. I think, as Lauren already said in the chat, we have office hours coming up with the solutions engineering team where we could talk a little bit more in depth about those direct connections and how you're able to get those with Kubernetes. So that's a great question, Alex. Definitely something that we need to think about when we're doing this kind of stuff. But generally, if you're using the same geographical regions with these two cloud providers, you will definitely get really, really low latency connections, even with a relay node. Eugene, since each exposed service or ingress appears as a device in Tailscale, one, do limitation on number of devices per account apply? And two, do they automatically disappear when the ingress objects are deprovisioned? So yes, they do count as devices, and so they do fall into the devices part of the limitations on the Tailscale SKUs. So for example, on a personal tier, you get 100 free devices out of the gate, and then you get 20 devices per user. So they do definitely apply, and they act as a device rather than a user. However, and on the other one, do they automatically disappear when ingress objects are provisioned? Yes, they do. The operator handles removing them for you. So if I deleted these, the operator would recognize that actual device had vanished and will delete it from the Tailscale console. So you would only be billed in terms of credits for the time that actual active device was alive. Hopefully that answers your question. So I was not planning on running a more down-to-earth example for this particular one, Morton, because we're really focusing here on the actual connectivity side of things rather than the actual kind of large language model stuff. I did run the kind of Docker example earlier on. Hopefully you got to saw that, and ran it on my local laptop. So we kind of went through a little journey of running through the connectivity on a local machine, on localhost, and then the connectivity over a standard Tailscale connection between a cloud provider and my machine, and then a more elaborate connectivity between two different Kubernetes clusters. Hopefully that answers your question. I wasn't planning on doing any more demo here. I'd love to get some feedback towards the end around the kind of things that you'd love to see in these webinars. Okay, so let's wrap up. I forgot to add the links here, so I will send out the links to the Git repo that has all this data in here. I've really enjoyed this process. The chat has been great to kind of keep an eye on in my second screen here. Really appreciate everybody kind of following along the kind words. Feedback is a gift. I would love to hear what you thought of this particular demo. If it hit the mark, if you found like it really helped you or saw a different way of doing things, if you thought it wasn't very good and you'd love to see different examples, please feel free to give that directly to me, at least lee@tailscale.com. But also please feel free to scan this QR code. It's just a few simple questions around what you thought of this, and rating from 1 to 5 should take on no longer than 30 seconds, and it really helps us build content that you folks really want to see. Thank you so much for everybody joining us today. It's been really fun. This was a brand new space for me to explore outside of my usual systems infrastructure and DevOps background, learning about large language models that I would happily give. Yeah. So here's the QR code again. Really appreciate everybody's time. Like I said, this is really outside of my usual wheelhouse around like infrastructure as code and systems information, so systems management and DevOps and SRE. I'm on the Tailscale Solutions Engineering team. We have an office hours once a month where you can bring any question about any topic to us for an hour period, and you'll just hear me and another colleague talking, chatting away about different things within Tailscale. Very similar format to this, quite informal, but generally questions based. So we'd love you to bring our questions to the next Tailscale office hours. The recording will be available and will be sent out to all the attendees. My wonderful co-hosts Tim and Lauren Aaron have been taking care of making sure the recording is there. But this has been a really great experience. So with that, I'm going to end. Oh, we have one more question right before the end. Hold on 1 second, Lee. Don't end things just yet. While I answer this other question, I'm going to send out one last Q&A, and then let's have a look here. So Francois has asked, would a solution like this be convenient to more easily bridge the gap between hosting providers which aren't on the same continent, for example, to use on reserve process? Absolutely. I have used the same geographical region for this particular demo because I'm on the West Coast of the US, but this definitely works across geographical regions with no problem. If you would like to hear more about that, please feel free to email SE, that's Sugar Echo, at tailscale.com, which will send emails to all of us on the solutions engineering team, and we'd love to talk more about the use case. But this will absolutely work across continents. We have Tailscale customers who are doing some really exciting things around the globe with connectivity along this line. I just used US West here just because it was more performant for the actual demo. So thanks very much, everybody. Really appreciate everybody's time. I'm going to close it down now, but looking forward to seeing you all at the Solutions Engineering office hours. And yes, it's se@tailscale.com, Francois. Yeah, looking forward to seeing more folks at the SE office hours, and thank you so much for the time.